All right. Hello, everyone, and welcome to the first talk of the beginner track for the day. Thank you all for coming and to learn about policy as code and Readable Rego. Quick show of hands. Who here is doing some sort of policy as code already in their stacks? All right, cool. And how many of you are already using Open Policy Agent? Okay, we got a couple. That's pretty good. All right. Well, this is the beginner track, so this is going to be a very introductory a talk on how to use Open Policy Agent, what it is, why it came about, and then we're just going to go over some quick examples of how to write Rego policies and how to clean up the code. So, starting off, my name is Peter O'Neill. I am a senior DevOps engineer and evangelist for a company called WebRiot. We help do digital transformations and helping companies move their legacy technologies to the cloud. Cool. So today's agenda, talk a little bit about why Open Policy Agent came about, the difference between auth-n and auth-z, a bit about what it means for something to be policy as code, then we'll dive into the Open Policy Agent project, and then we'll get into writing Rego and doing some unit testing. So let's get started. So you've probably already seen something similar to this where, we've been moving to the cloud, we've taken these monoliths that we had, and we've broken them down into these microservices, and breaking them into their smallest components. And so when this happens, there are a lot of points now that you have to make decisions, Now that we have all these different services, all of these services have API endpoints, and then you have more users using these services, and all these services have more components. So now you can see the complexity here of all of these points. Now you have thousands of interactions that need some sort of authorization check when they happen, And so this is now why we move into the space, why we need a more fine-grained access control system or authorization tool. And so the reasons that a coarse-grained system, we're talking very simple like RBAC policies or just users, where you can just have one simple rule around what a user can or can't do won't work, It kind of lacks a lot of the complexities that our cloud-native systems need, And so when we talk about this, these policies end up being hard-coded directly into the application, they end up being very error-prone, There's a lot of things that just don't work very well for the complexities of the systems that we want to create. And so with that, we want to now extend and expand what we're doing to be more dynamic and to be more inclusive of the systems that we're creating, And so this is kind of the model that we want to move into. So with that, we'll move into auth-n versus auth-z, and this ends up being a question that comes up quite a bit when people are trying to adopt an authorization system because they think, I already have an SSO provider, I already know, I already have something that identifies my users. But this is the auth-n side of the problem, and when we have, but we need both sides of this coin, Not only do we need to identify the user, but we need to grant permissions in a way that is very modular, So you need to solve both sides of this coin in order to have a true authorization system, And so when we're on the auth-n side, that is our SSO provider, that could be LDAP, that could be Active Directory, And then on the other side of that is when we're actually setting up our authorization system, And this could be as simple as RBAC, Once again, that very coarse-grained, just understanding what users belong to what groups and giving them permissions based on that. And then you have, you move into a little bit more complexity where you have an ABAC system or attribute-based access controls where you start defining more attributes around each specific user and each interaction that they're doing. And it gives you a little bit more of that fine-grained nature, or something like IAM, directly in your cloud, where you can control individual components within the cloud. And so it's giving you more and more control over the interactions that need to happen. And so when we think about this, we can think about all the different places that these interactions are happening, You can have things at the infrastructure layer, directly on Kubernetes or Docker, or you can think of this as inside Kubernetes, you have your admission controller. This is when Kubernetes is actually going to create resources, We are admitting those resources into Kubernetes, So we need to have that modularity to say, hey, I want specific users or specific service accounts or specific X to be able to create some type of resource in this cluster. You want to be able to control what that looks like, right? Same thing with Terraform. You want to be able to say, when I run my Terraform plan, I know what is in scope and what is out of scope, right? I know that when users are creating resources, VMs, maybe entire clusters, right? You want to know exactly how they should be created, not just saying because you are an admin, you can create whatever you want, right? This ends up happening a lot in CI/CD pipelines where those permissions end up getting like the star value admin, and those CI/CD pipelines end up being overpowered for what they need to do, right? And then on the application side of this, right, you can think of this as when you are defining your applications, when you are building these services, what exactly are you going to allow your users to actually do when they're interacting with the system, right? And so these are all different types of authorization decisions that need to happen both on the infrastructure side and on the application side. And so what's needed, right? And so this is kind of where we start getting into this policy as code mindset, right? Where now that we're looking for this dynamic fine-grained authorization, right, we start wanting to standardize this by using some sort of framework, right? And by having a framework, now we know for all these different components, from the infrastructure all the way up to the application, right, we can start defining what these policies look like in one language, right? And we want to be able to say, well, how do we do this in one place, right? How do we actually get these policies to apply to all of these different areas? And we do this by decoupling the policy logic from the tools that we're using, right? And so this is where we start actually doing policy as code, because now that we have decoupled what authorization checks need to happen, now we can start defining these and putting them into our policy, or start checking these into Git as if, like we will with the rest of our code base. Right, and so now we know a little bit about policy as code, or sorry, one more slide here. Right, and so the evolution of policy, right? And so this is kind of where we started to how we got to policy as code. And so, right, once upon a time, right, like I remember my first job, my first systems job, where they gave me access to all the systems when I started, right? They created all my accounts, and it's basically just root access to everything, right? It was basically them saying, hey, when you're working with our systems, make sure you don't do this. And everything was written in a wiki, and who really reads the wiki every time they go to do something, right? Like it's not something that you're going and manually checking to make sure you're doing the right thing every time, and so it's very error-prone. And then so, right, as things kind of moved along, we started saying, well, okay, well, now I can just kind of put some guardrails up and just kind of say, let the system block a few things here and there, right, and make sure the system stops you from doing anything that's like crucially bad. And then, right, and then this worked fairly well, but we ended up defining things like who is my admin group in a dozen different places, right? And so we had this hard-coded policies that needed to be rewritten time and time again, right? And so this is where we've now moved into, right, like, okay, well then, how do we define this in one place and spread it out everywhere, right? Giving us this more of a policy as code mindset, right? And so when we're doing this, what we're doing is we are extracting that policy, writing it in some sort of policy language, and then having a policy engine enforce this for that service, right? And so now we have whatever that service is being able to call out to that policy engine, right? Maybe it's running directly on the service, maybe it's running next to the service, but that service now is able to make that call to say, hey, I don't know what to do in this scenario, and you don't want it to know, right? You want your policy system to be able to make those decisions for it, right? So this ends up taking away complexity from the service and speeding up that check every time it needs to happen. Right, and so as we're doing this, right, what we're doing is we are applying the same principles that we use for software development for our policy, right? And so when we typically think about how we've come to build applications, we have this very standard idea of what the software development lifecycle is, and those same practices work for your policy development lifecycle, right? you want to be able to define things up front. You want to be able to author and create things and check them into Git before you're actually deploying them so that you can run your unit tests, your integration tests, right? You can verify everything that's happening before it goes into your systems because, right, like you don't want to check in a policy that's very restrictive and have it, block access that you need or turn off access that's already there, causing things to happen that are unintended, right? And so you're able to use that same CI/CD pipeline to deploy policies that create the security guardrails, but you're able to use this with the same tools and mindset that you're used to for when you're doing your software development, right? And then it gives you additional things like monitoring and logging, all the other additions to the lifecycle that you want to see. And so with that, right, we have this tool called Open Policy Agent, right? An Open Policy Agent has been around for quite a while. It is a graduated project in the CNCF. And right, it came about to solve this problem of how do we enable authorization across the tech stack, or across specifically your tech stack that you're using, right? And it does this by creating that standardized policy framework that we talked about earlier, right? And so OPA, or OPA for Open Policy Agent, is a general purpose policy engine, right? That general purpose meaning that it's able to be used for all those tools and services, right? And so this tool, right, by decoupling, actually we'll get to that in the next slide, right, is going to allow you to really optimize your policy performance, for the rest of your stack, right? And so how exactly does this work, right? And so as I mentioned, we are decoupling here. So the service at the top here is going to make, right, maybe this is going to be an HTTP call. Maybe this is going to be running as like a sidecar, right? But you're going to have these various options so that your service, right, can ask a question. And what is a question? A question is going to be all of the input and data that your service has, and it's going to ship that as a JSON object to Open Policy Agent, right? And so we are calling this a question, but realistically, this is just understanding the data in and returning a data block back, right? And so at its simplest level, what you might be returning back is like a Boolean, like a true or false, but this could be much more complex than that as well, right? You might want to send some sort of JWT token that you want to encrypt or decrypt. You might want to hash these values or create certificates on the fly, right? So OPA being this, being the decision engine, just understands how to take in this JSON, and then you're going to define with your policies what needs to be sent back, right? And so the magic happens inside of the policy itself because the policy is going to transform this data into what you need, right? And so, right, like as I mentioned, right, there's a bunch. This is going to work with pretty much any of the tools in your tool stack because as a cloud-native tool, everything basically speaks on the HTTP protocol. So you're able to send these requests, and then OPA will be able to compare the question coming in with the policies that are defined and any external data that you want to give it as well, right? That external data might be user data, it might be right, just situational data. It could just be right, like anything that's going to augment that policy to allow OPA to make the correct decision for what needs to happen. And so, right, like we typically are going to start at one place inside of your tech stack, but right, these decisions, once again, happen throughout the entirety of your application. So you're going to insert where these policies happen at all of these different components, right? You're going to check when things are being created in your CI/CD pipeline. The policies are going to be applied there so that you know things are created in the right way. You're going to include policies in between your services, right? Like, so if you're using some sort of service mesh or something that is giving you that telemetry between all of your services, you want to know that what's happening when those calls go from service A to service B, that everything is happening as you expect it to, right? And then down on the infrastructure layer, you want to make sure that things are always in the form and fashion that they should be, right? Understanding what the state of your system looks like and how it should look, right? And how you're going to want it to be, right? So you can see how very quickly all of these different components are requiring some sort of policy that you're going to want to put in place. And so you also want to define what those look like and be able to reuse them, right? You want to keep your policy infrastructure as simple as possible. And once again, we're doing this by decoupling where that policy enforcement happens, right? And we're handing it off to Open Policy Agent so that all the tools you see here on the screen can speak one language when they want to make this decision. Right, and here are some very common use cases and patterns. I've kind of touched on these already, right? But Kubernetes with the admission controller is a very popular one. If you've been involved with the Open Policy Agent project, you've probably heard of Gatekeeper, and Gatekeeper is essentially a framework on top of Open Policy Agent, which turns your Rego policies into CRDs so that you can apply them in the cluster, right? And then there's tools like Terraform, which you can run either directly in like Terraform Cloud, where they have an Open Policy Agent run task, or you can do this on your own in your CI/CD pipeline by introducing OPA as like an action or just a component within your CI/CD kind of process. And then with Envoy, right, we interact directly with Envoy through their APIs so that we can understand what's happening and make decisions from service to service very quickly, so we can implement those policies without introducing additional legacy or latency, right? Or Open Policy Agent is a very small Go binary, so you can actually run, or you can create things that are very performant for your specific use cases, right? We have a Go wrapper around Open Policy Agent, which is very performant. We've seen some very interesting deployments of this. One very recent one that I saw was Miro basically understanding all of the interactions on a Miro board and then shoving them through a data pipeline to understand what the permissions are on the Miro board in real time, which is very impressive when you think about it, because there may be dozens or 100 users interacting with the board with 1,000 components. So the complexity there of who's allowed to mess with which components at which time ends up scaling into the thousands of decisions a second very quickly. So you need to be able to create something that, or create a pipeline of authorization decisions that's very robust. Right, and so when we're doing this, right, like this was the this was what I showed earlier, right? And we're basically just replacing a policy engine with Open Policy Agent specifically, right? OPA is the tool that we want to use, and Rego is the purpose-built policy language that we want to write things in. And so now we're going to dig into Open Policy, or sorry, Rego, which is, as I mentioned, the purpose-built policy language, right? And so when I say purpose-built, what I mean is that it was created alongside Open Policy Agent to define what our policies look like, right? And so there was large discussions in the beginning around what should a policy language look like? Should we just repurpose Python or JavaScript or Golang, or just try to write things in a language that people already understand? The problem with that was that you're bringing in all of the baggage of that language that people want to write things in a specific way. And so trying to stick to a cloud-native mindset is having a declarative language ended up feeling much more natural to solve this problem, right? And so now we have this declarative language where we want to define what our policy is going to do, and you're able to state this in a clear fashion that now Open Policy Agent figures out what it needs to do. And so since most people in this room haven't written any Rego before, what we're going to do is we're going to write a simple policy here, which is just around RBAC and controlling or defining what a specific user can do, right? And so here on the screen, I'm showing some data in these pink boxes at the bottom. I'm going to abstract a lot of this away, but that's kind of just like the small data block that we're working with here. And so with that, right, on the left-hand side here, we have a package name, right? And this package name is a naming convention, right? The naming convention is just a logical boundary between your policies, right? So this is a full-featured coding language, and so we have this logical boundary in order to say, like, oh, I have a package of policies for my AWS features. I have a package of policies for my Microsoft or Azure resources, right? So you just want to be able to have that logical boundary so that you can call policies from one side and reuse them maybe between teams or just between policies, right? And then next up, we have this word called import. And so with import, what we're doing is we are protecting backwards compatibility, right? And so this is very important when you're dealing with policies and you want to know that what you're doing is not going to break what already exists, right? Because breaking things that exist with a policy could have catastrophic effects. And so what we end up doing is, as we advance the language, we wrap all these features into this future keywords import. And so this ends up allowing us to read the policy in a much more, in a language, or make it seem much more like English as you're reading the policies. And then so next up is, right, we have a declarative language, and declarative languages don't really like when things are undefined. And so you end up wanting to set a baseline for what each of your rules is going to be at the beginning, right? And so very typically, you're going to have like an allow equals false as a default, and this kind of just says, right, fail close, don't allow things to happen that aren't intended. And then now that we have our defaults, we're starting to abstract more of the policy away at the top, but it's all still there, right? So now, right, this very simple rule of like allow admins, what we're doing here is, right, we have one rule, which is that allow rule, but we are now calling out to a helper function. This helper function is going to be what actually runs the logic. And so in here, we can see user is an admin if admin is in data.user roles, and we're checking for that specific input.user, right? And so that input user on the right-hand side there in the white box, right? This is going to be what is shipped from the service asking the question. So in this case, we're thinking about like an API request for a user trying to perform some sort of action on a specific object with that ID and the type dog, right? And so what we're doing now is we are basically looking up that user that we see is Alice in the box and trying to and seeing what role Alice has assigned. And so in here we can see that Alice is an admin, so this rule would become true, right? And so, but what if Alice isn't an admin, right? And so now we end up having to be a little bit more granular around what this rule is going to do. And so this is, right, so now we're breaking this down a little bit further, and we're actually checking for these specific grants that are tied to this user, right? And so remember, all of the information coming in is JSON, so we're able to navigate this JSON tree just by doing this like dot notation, right? And so we can see in this allow if statement, right, we are checking for a grant in this user is granted kind of rules, or in this rule called user is granted, right? And so at the second part of this rule, we could see that we are kind of going through the list of roles, and in that list of roles, we are checking for grants, right? And so what we are looking for here in the input box, right, we can see Bob is trying to do an action called update on object ID 456 with type cat, right? And so we are looking through this data set on the right-hand side, and we're seeing that it doesn't quite match up, right? Bob doesn't have this type cat assigned to him, right? So as we are cycling through the roles and grants that Bob has assigned to him, we are seeing that he doesn't quite have the permissions that he needs. And so as Rego is going through this list, right, and when these things don't match, these rules become, right, defaults back to that default equals allow equals false, right? And so with that, right, like that is just a very simple policy that we've written, right? And so this is typically what we end up telling people to do is like start really small. Find one very small rule or around what you want to define or protect with this policy, and then expand from there. And so now that we have our first rule written, right, like with any good coding practice, we're going to write our unit tests around the rule. So with these unit tests, the language makes it very simple, right? And we normally recommend that you separate out your unit test into a separate folder. So this one is just rbac.tests, right? And you're going to define these tests with this test underscore keyword at the front. And what I'm doing here is supplying it with like a mock data, right? So before we had the input that was coming in that JSON object, here we are just essentially saying, imagine that this is the input, and we're saying what we're expecting to happen, right? And we're expecting this allow to be true when the input shows Alice update and then type cat, right? And so if you're doing any sort of good test-driven development, right, you're going to be able to define all of your unit tests up front to do this. And so with the inverse of that, right, being able to see that this negative test, not allow, is also going to right, not allow being true because we're expecting it to be false. And so with that, the very last section here is kind of just improving your Rego, right? And so these are just common things that we see. Right, so on the left-hand side is, as people are kind of learning the language, it ends up not being super clear, right? The left and right-hand side here both do the exact same thing, but you're going to see as you progress in your learning of the language, right, you start using more of the features, you start using annotations instead of just comments. You're now also like using rule names that make more sense, right? It ends up being very common that when you write your first rules, you write something that sounds very easy to remember, but then maybe isn't super clear when you're looking at it and reviewing it, right? So having a super user rule may not be the clearest thing when you're trying to review the audit logs, right? But using rule names like allow lets you know that, okay, so this rule was trying to allow something to happen, right? And so the second thing here is reusing expensive computations, right? And so on the left-hand side here, or in the red box, right, we're going to see that in both of them, we're doing the same check instead of using a helper function, right? This helper function is what's actually going to, when you're scaling out and you're doing things at a much bigger scale, you're going to want to be able to use these helper functions to reduce the number of iterations and calls that you're making, right? And so these reusing expensive computations isn't just for iteration, but also when you're making like HTTP calls or using external data to pull that information in. And then my last one here is just nested iteration, right? And this is something that also very common when you write your first rules is it ends up being very simple to just loop through your loops when you're checking for things. But right, then you end up with these coding problems where things take much longer than you expected, and you end up trying to solve performance problems later down the line instead of defining a list that you or a set that you can reach out to, right? And so making information reusable is a big part of writing code that is very performance. And so with that, I just want to say thanks. This is a quick primer on OPA and Rego, and yeah, thanks for attending. Cool. And I think we have 1 minute if there's any questions. Yes?
So you mentioned performance and latency impact in general. How does one measure the impact that using OPA has? So for example, is there a metric exported where I can measure, okay, there's more latency introduced into the system because we've just deployed OPA.
Cool. All right. So the question was, how would you measure performance, right? If as you are introducing these policies, right? How do you see what's happening? And so there are two things there, right? One is on the OPA side of things. As you are defining them, you can run what we have a policy benchmarking performance tool built into the CLI, so you can actually see like how much time down to like the nanosecond that each policy takes to run. And this is where you can very easily see spikes when you have like nested iteration. These become very apparent that certain rules take much longer than expected. And then on the other side of that is what you wanting to kind of measure just end-to-end latency to see if anything has changed with these policies, or kind of two places that you could look when you are trying to measure what the performance impact is like. Cool. What do you mean by export?
I can have like dashboards set up and measure specifically performance.
Got it. Yes. And so with dashboarding, yeah, you can set it up to export information, right? Like OPA has management APIs that you can pull all this information out of. Okay, and with that, I think I'm actually at time. So thank you, everyone.